Modern residential dimmers predominantly utilize triad for alternating current semiconductor switches to perform the dimming function. Triacs are three-terminal electronic components specifically designed to control alternating current power. They act as bidirectional switches, allowing current to flow in both directions, and offer smooth and efficient dimming by varying the portion of the alternating current waveform that is allowed to pass through. In a typical residential dimmer circuit, the triac is connected in series with the load, for example, the light bulb. When a control signal is applied to the dimmer's control terminal, it triggers the triac to turn on at a specific point in the alternating current waveform. By varying the timing of this trigger point, the dimmer effectively controls the fraction of the alternating current waveform that reaches the load, resulting in adjustable brightness levels. Compared to older dimmer designs that employed silicon-controlled rectifiers, Triacs offer several advantages. Firstly, bidirectional control. Silicon-controlled rectifiers can only conduct current in one direction, which limits their use in alternating current circuits. Triacs, on the other hand, can conduct in both directions, allowing them to control alternating current power effectively. Secondly, smooth dimming. Triacs provide smooth and gradual dimming over a wide range of brightness levels. They achieve this by controlling the amount of alternating current waveform that is allowed to pass through, rather than simply switching the power on or off like traditional on or off switches. Thirdly, energy efficiency. Triacs are relatively efficient in their operation, minimizing power loss during the dimming process. This contributes to energy savings compared to older dimmer designs. Fourthly, compact size. Triacs are relatively compact and can be easily integrated into modern dimmer devices without taking up excessive space. Overall, Triacs have become the preferred choice for residential dimmers due to their bidirectional control, smooth dimming capabilities, energy efficiency, and compact size. They offer a reliable and efficient method of controlling lighting brightness in homes and other residential settings. Let's delve a little deeper into the workings of Triacs and how they achieve their dimming capabilities. At its core, a triac is a three-terminal semiconductor device that acts like an electronic switch. Unlike a simple on or off switch, however, a triac can control the amount of alternating current power that flows through it. This control is achieved by varying the point in the alternating current waveform at which the triac turns on. The alternating current waveform is a sinusoidal wave that alternates between positive and negative voltage. In a standard alternating current circuit, the voltage rises from 0 to a peak positive value, then falls back to 0, reverses polarity, and falls to a peak negative value, before rising back to 0 again. This cycle repeats continuously. The key to dimming with a triac lies in controlling when the triac begins conducting current during each half cycle of the alternating current waveform. When the dimmer is set to full brightness, the triac is triggered to turn on very early in each half cycle, allowing almost the entire alternating current waveform to pass through to the load. This results in the light bulb receiving maximum power and emitting full brightness. As the dimmer is adjusted to reduce the brightness, the triac is triggered to turn on later in each half cycle. This means that only a portion of the alternating current waveform is allowed to pass through to the load, reducing the amount of power delivered to the light bulb. The later the triac is triggered, the smaller the portion of the alternating current waveform that passes through, and the dimmer the light becomes. The process of triggering the triac is typically controlled by a small electronic circuit within the dimmer switch. This circuit uses a potentiometer, which is a variable resistor, to adjust the timing of the trigger signal. When the user turns the dimmer knob or slides the dimmer switch, they are changing the resistance of the potentiometer, which in turn changes the timing of the trigger signal sent to the triac. The triac itself consists of several layers of semiconductor material arranged in a specific configuration. These layers create two internal silicon-controlled rectifiers that are connected in reverse parallel. This configuration allows the triac to conduct current in both directions, making it suitable for alternating current circuits. When a trigger signal is applied to the gate terminal of the triac, it causes one of the internal silicon-controlled rectifiers to turn on, depending on the polarity of the alternating current voltage at that moment. Once one of the silicon-controlled rectifiers is turned on, it remains on until the current through the triac falls below a certain threshold, known as the holding current. This ensures that the triac continues to conduct current for the remainder of the half cycle, even after the trigger signal is removed. As the alternating current voltage crosses zero, the current through the triac also drops to zero, causing both internal silicon-controlled rectifiers to turn off. The triac remains off until the next trigger signal is applied during the next half cycle. This process repeats continuously, allowing the dimmer to control the brightness of the light bulb by varying the portion of the alternating current waveform that is allowed to pass through. One of the significant advantages of using triacs and dimmers is their efficiency. Because triacs are semiconductor devices, they have very low resistance when they are turned on. This means that very little power is lost as heat when the triac is conducting current. This is in contrast to older dimmer designs that used resistors to reduce the voltage to the light bulb. Resistors dissipate power as heat, making them much less efficient than triacs. In addition to their efficiency, triacs are also relatively small and inexpensive. This makes them a cost-effective solution for dimming applications. They are also very reliable and have a long lifespan. However, triacs are not without their limitations. One potential issue is that they can generate electromagnetic interference, also known as radio frequency interference, when they switch on and off. This interference can potentially disrupt other electronic devices in the vicinity. To mitigate this issue, many dimmer switches include filters that suppress the electromagnetic interference. Another potential issue is that triacs can sometimes produce a buzzing sound when they are operating at certain dimming levels. This buzzing is caused by the rapid switching of the triac and can be annoying to some people. To minimize this buzzing, some dimmer switches use special triacs that are designed to operate more quietly. When selecting a dimmer switch, it is important to choose one that is compatible with the type of light bulb being used. Some light bulbs, such as compact fluorescent lamps and light-emitting diode lamps, require special dimmer switches that are designed to work with their unique characteristics. Using an incompatible dimmer switch can cause the light bulb to flicker, buzz, or even fail prematurely. In conclusion, modern residential dimmers predominantly use triacs to control the brightness of lights. Triacs are efficient, reliable, and cost-effective semiconductor devices that offer smooth and gradual dimming over a wide range of brightness levels. They work by varying the point in the alternating current waveform at which they turn on, allowing only a portion of the alternating current waveform to pass through to the load. While triacs have some limitations, such as the potential to generate electromagnetic interference and buzzing sounds, these issues can be mitigated by using appropriate filters and triac designs. When selecting a dimmer switch, it is important to choose one that is compatible with the type of light bulb being used to ensure optimal performance and longevity. Let's further examine some of the components and operational principles involved in triac-based dimmers. A typical triac dimmer circuit consists of several key components, including the triac itself, a diac, a capacitor, a resistor, and a potentiometer. The triac, as previously discussed, is the main switching element that controls the flow of alternating current power to the light bulb. The diac is a two-terminal semiconductor device that acts as a trigger for the triac. It has a specific breakover voltage, and when the voltage across the diac reaches this level, it conducts current and sends a trigger pulse to the gate of the triac. The capacitor and resistor form a timing circuit that controls the charging rate of the capacitor. The potentiometer, also known as a variable resistor, allows the user to adjust the charging rate of the capacitor, which in turn controls the timing of the trigger pulse sent to the diac. The operation of the circuit can be described as follows. When the alternating current voltage is applied to the circuit, the capacitor begins to charge through the resistor and potentiometer. The rate at which the capacitor charges is determined by the combined resistance of the resistor and the potentiometer. As the capacitor charges, the voltage across it increases. When the voltage across the capacitor reaches the breakover voltage of the diac conducts current and sends a trigger pulse to the gate of the triac. The trigger pulse causes the triac to turn on, allowing current to flow through the light bulb. The triac remains on until the alternating current voltage crosses zero, at which point the current through the triac drops to zero and the triac turns off. The capacitor then begins to charge again during the next half cycle of the alternating current voltage, and the process repeats. By adjusting the potentiometer, the user can change the charging rate of the capacitor, which in turn changes the timing of the trigger pulse sent to the diac. This allows the user to control the point in the alternating current waveform at which the triac turns on, and thus control the brightness of the light bulb. There are different types of triac dimmers available, each with its own advantages and disadvantages. One common type is the leading edge dimmer, which turns on the triac at the beginning of each half cycle of the alternating current voltage. Leading edge dimmers are relatively simple and inexpensive, but they can sometimes cause flickering or buzzing, especially with certain types of light bulbs. Another type is the trailing edge dimmer, which turns on the triac at the end of each half cycle of the alternating current voltage. Trailing edge dimmers are more complex and expensive than leading edge dimmers, but they typically provide smoother and quieter dimming, especially with light-emitting diode lamps and compact fluorescent lamps. Another factor to consider when selecting a triac dimmer is its power rating. The power rating of a dimmer indicates the maximum amount of power that it can handle. It is important to choose a dimmer with a power rating that is sufficient for the light bulb or light bulbs that will be connected to it. Using a dimmer with an insufficient power rating can cause it to overheat and fail. In addition to traditional knob or slide dimmers, there are also electronic dimmers available that use microcontrollers and other electronic components to control the dimming function. Electronic dimmers offer more advanced features, such as preset dimming levels, remote control, and the ability to integrate with home automation systems. They can also provide smoother and more precise dimming than traditional triac dimmers. Furthermore, the installation of residential dimmers requires careful attention to safety and adherence to electrical codes. Firstly, always turn off the power at the circuit breaker before working on any electrical wiring. This will prevent electrical shock and ensure your safety. Secondly, identify the existing wiring connections. Typically, there will be 2 or 3 wires connected to the existing switch. These wires may be color-coded, with black usually indicating the hot wire, white indicating the neutral wire, and green or bare copper indicating the ground wire. However, it's crucial to verify the wiring configuration with a voltage tester to ensure accurate identification. Thirdly, disconnect the existing switch. Carefully disconnect the wires from the existing switch, using a screwdriver to loosen the screws or release the terminals. Take note of the wire connections for reference during the dimmer installation. Fourthly, connect the dimmer wires. Refer to the dimmer's instructions for the correct wiring configuration. Typically, the dimmer will have wires or terminals with the hot, neutral, and ground wires. Connect the corresponding wires from the electrical box to the dimmer, ensuring secure and tight connections. Fifthly, mount the dimmer switch. Carefully mount the dimmer switch into the electrical box, aligning it with the screw holes. Secure the dimmer with screws, ensuring it is firmly in place. Sixthly, attach the faceplate. Snap or screw the faceplate onto the dimmer switch to conceal the wiring and provide a finished look. Seventhly, restore power and test. Turn the power back on at the circuit breaker and test the dimmer switch to ensure it functions properly. Adjust the dimmer to different brightness levels to verify smooth and consistent dimming. Remember that local electrical codes and regulations may vary. It is essential to consult with a qualified electrician if you are unsure about any aspect of the installation process or if you encounter any difficulties. Proper installation and adherence to safety guidelines are crucial to prevent electrical hazards and ensure the safe and reliable operation of the dimmer. In summary, triac-based dimmers are widely used in residential settings due to their efficiency, cost-effectiveness, and smooth dimming capabilities. They consist of several key components, including the triac, diac, capacitor, resistor, and potentiometer, which work together to control the flow of alternating current power to the light bulb. Different types of triac dimmers are available, such as leading edge and trailing edge dimmers, each with its own characteristics. When selecting a triac dimmer, it is important to consider its power rating and compatibility with the type of light bulb being used. Proper installation and adherence to safety guidelines are essential to ensure the safe and reliable operation of the dimmer. Furthermore, the evolution of lighting technology has led to the development of advanced dimmer designs that incorporate electronic components and offer enhanced features. These advancements continue to improve the performance, efficiency, and user experience of residential dimmers.